Variants of boosting have been used online to improve search results, on images to better find objects, and on music to enhance the ability to detect emotions. Boosting is another method of ensembling machine learning models, similar to bagging. In contrast with bagging, though, boosting iteratively creates new models by training the models to better learn the data that the previous model misclassified. Boosting starts with training a model on the original dataset normally. Then for every example that was misclassified, they increase the weights, and for every example that they classified correctly, they decrease the weights. The weights here are ways of mathematically expressing the importance of a training sample to our model. The higher the weight, the more the model tries to learn to predict that example correctly. So the new classifier is trained on the weighted data, and then we see what examples it got right and what examples it got wrong, reweight the data, and repeat it again until we have a number of models. The prediction for this ensemble is a weighted sum of all the models we trained. The weights here are based on the percentage of the data each model predicted correctly. This allows us to combine all the model's predictions and adjust the result based on how confident we are in each of our models. Overall, boosting's super nice. It's often used when trying to increase performance, especially if you are trying to increase performance on harder or less common examples. It can give better performance increases compared to bagging, but it's also slower to train. One potential thing you might have noticed is that boosting can learn bad examples that a normal model would have ignored. It could learn to predict examples that are incorrectly labeled. How would you change boosting to fix this issue?